So these are our learning intentions. We want to solve problems involving surface area of prisms, and also to understand the practical uses of calculating surface area, right? So I've put this a task for you on Maths Online that you can do as your homework, okay? So let's probably start with our warm-up question today. What I want you to do is to draw and name as many 3D shapes as you can, and maybe draw the net of these shapes. So what do we mean when we say a net? So I'll give you an example. Maybe the easiest one would probably be a cube. So let's draw a cube here, and it's a 3D shape because it's got 3 dimensions: the length, the width, and the breadth, right? So that's what it looks like as the 3D shape. But when I have a net, then I would have this. So imagine that you flatten that box, and what would the box look like, or what shape would the box form, or the covering form? Okay, so we want to draw and name as many of them, and I've given you a few of them as a drawing, so you might want to just draw their nets, or maybe name them as well. And how do we name them? Okay. So these are all 3D shapes. What's the same? What's different? What would be, looking at these 2 sets of shapes, what would be the same from this group and this group here, and what would be different between them? Okay, I'll give you maybe 5 minutes to do that and think about that. And then you can pause this video and then log on later. All right, so if you would have guessed what's the same, what's different, well, looking at this one here, this one would have what? The same shape, right? That one's a square, that's also a square there. That one's a rectangle, that one is also a rectangle there. This one's a pentagon and a pentagon here. But what's different? So what's different is that if you slice these shapes, these ones here, if you slice them, then all the slices would be uniform in shape, right? And in size, okay? But if you do that for this one here, then if you slice them, all the slices would get smaller and smaller and smaller, right? Until you just have a dot. The same thing with all these other shapes here, right? So the ones on top, we call them, if you knew already, those are what we call prisms. And those are the shapes that we will be focusing on today, right? And the ones on the bottom are what we call our pyramids. Okay. So how would you define a prism, knowing that what's the same, what's different between these 2 shapes of 2 groups of shapes? How would you define a prism? Okay, so I'll give you a minute to do that as well. Write it down in your book. And how do you name these prisms or even these pyramids? Okay, so if you were able to figure out that the first figure here is what we call a triangular prism, then you're correct. On the bottom, that's what you call a triangular pyramid, right? Now, the second shape there, which is the green one, you call that a square prism. The purple one is what we call a rectangular prism, etc., etc. So because the cross section here is a pentagon, then you would say that this one here is a pentagonal prism. This one is a hexagonal prism. And how many sides would this be? You've got 1, 2, 3, 4, 5, 6, 7, 8. It's an octagonal prism, right? So these shapes, these 3D shapes, these prisms are named after their cross section, right? The cross section would be the slice, okay? And the same thing how you'd name your pyramids. So looking at these shapes here, well, what do mathematicians want to know about these shapes, right? What do we want to know about, how these shapes are used? If we are going to use them, what do we want to know about these shapes, right? I'll give you a clue. Well, we've got these here. We've got several packagings here, and they all look like 3D shapes, right? And with these packaging, what we want to know is how much can we fit inside those packaging, right? And it's not only how much we can fit inside that packaging, but also how much material are we going to use so that we can create these packaging, right? So two things that we said about these 3D shapes. One, how much can you put inside that shape? Another one is how much material do you need to make up that shape, right? And those are the two things that we want to learn in this unit. One is what we call the volume, which is the last one we're actually be talking about. And the volume is how much we can fit inside that shape. And the other one is what we call the surface area, which is how much material do we need to be able to build that shape, okay, or that container, okay? And those are the two things that we want to consider when we're talking about 3D shapes, right? So as I've said, this is the star of the day, or maybe the next lesson as well would be this, that's the star of the day, right? And we'll be looking at volume next term, okay? Right, so maybe a few questions, and I don't know if we've answered some of them. What is surface area? Okay, so, well, what we said was that how much material do we need to come up with that container? That's the surface area. And the reason why I asked you to draw the net of a shape, it's because the surface area is actually getting the area of each of those faces, right? So if you flatten that shape, and you have this face here and all these 6 faces of a cube, you want to get the area of each of the faces and add them together, and that's your surface area, because it makes sense that that tells us how much material we need to make up that shape, okay? How about the next one? What do you measure when you find the surface area of the shape? It's the amount of material that we need to be able to build that container, okay? And these are some words that you want to consider, and maybe those are the things that you will be able to find when you look at your textbook and read your textbook, and maybe answer some of the questions that they've suggested you to answer. Right, so the first one we mentioned already, it's a cross section, it's the slice, it's the shape of a slice of that 3D shape, okay? And when you do slice them, you don't want to be slicing them this way, right? But you want to slice it so that you've got even shape when you slice them, or the size would be the same when you slice them, okay? Polygon, well, polygons would just be a closed figure which would have faces. So a pentagon is a polygon, a hexagon would be a polygon, etc., right? So maybe another one would be a closed solid and an open solid, and we'll have a couple of examples that we'll be discussing today. And maybe you want to find out what would be the parts of a prism. Vertices would just be a plural form for vertex. You've got your edges. These are what you call your edges, right? And your faces would be that shape there, okay? Right, so let's probably have a look at this first example here. We want to find the surface area of this prism here, the dimensions of this prism are given, and what we have here as an added information is that it's an open rectangular prism. So when it says it's open, it's like a box without the top lid, okay? So as I've said, what we want to do when we're calculating the surface area, we're calculating the area of each of the faces, right? And then putting and adding them together, right? So the trick there is for you to figure out maybe what are the opposite faces, because these opposite faces would have the same area. What do I mean? Well, this one here would have the same area as this one, and those are your opposite faces, right? There's another opposite face. You've got the front here and the back, right? And when you have these opposite faces, then you don't have to double your work, right? You just need to times it by 2, okay? So let's do that. So when you want to calculate the surface area, you might want to be clearer with your working out by writing down what you're actually calculating. So you could probably say just what we said a while ago. You've got the front and the back. And then what do we need to add? The left side and the right side, and then the bottom. Okay, we don't have the top because it's an open rectangular prism. Okay, so how do we figure out the area of the front and the back? Well, this one says it's 7 by 3. And from our lesson yesterday, we said that the area of a rectangle would just be the length times the width. So that's 7 times 3. But then it would have the same area as the back. And therefore, we just times it by 2, right? The left side and the right side. So let's have a look at just the right side here. And that would be 6 times 3. And then there's 2 lots of them. And then the bottom bit would just be 7 times 6. And there's only one of that. Right. And what do we have? We've got 21 times 2, you get 42. 6 times, you could probably say 6, and that's 36. We use our associative law. 7 times 6, you get 42. Okay. And we can add 42 and 42, that's 84. 84 plus 36 would be what? 84, 90, 90 plus 30, you get 120, right? And of course, it's square meters, right? A more fun shape would be a triangular prism. As we all know, we've got the cross section as a triangle. That shape there is a triangle, is a triangular prism, right? So we do it just like what we did with the previous one. We would be assuming that it would be a closed prism unless it's stated that it's open, right? So that we have the front and the back. What else is here? We add maybe what? The top. We've got the bottom. And then on this, and one on the side. So what that side is this one here. Okay, so let's do that. Have we gotten all our shapes here? Let's find out how many faces do we have. So that's one way to check. So you go 1, 2, 3, 4, 5. So you've got 5 faces, and therefore you've got 1, 2, 3, 4, 5 sides. Yeah, 4 faces. So let's calculate them. The front and the back would be the same. They are both triangle. And the formula for the triangle, for the area of a triangle, is half times base times height. What is the base of this triangle? You could say that's 12. What is the height of that triangle? You could say that's 5, and we just double it. Yeah. Now the top, this top here would be 12 times 4. the bottom, which is the diagonal rectangle or the rectangular face, right? Which is what? 4 times 13. And then I don't have any space for the other bit there, but I can actually move that. Yeah, right. And then the side here would just be 4 times 5. Okay, so for us to have an A's in our calculation, you could probably say, let's cancel the half and the 2 there. So we're really just calculating what's 12 times 5. How do we multiply 12 times 5? You could probably say it's 12 times 10 divided by 2. 12 times 10 is 120 divided by 2. You get 60, right? You've got 12 times 4. How do we multiply by 4? We double it twice. So double 12 is 24. Double 24 is what? 48. And then 4 times 13, we can do the same trick, right? So you go 13 is double 13 is 26. Double 26 is 52, right? Or from your calculation previously, because you know that's 12 times 4, you just add another 4. So 48 plus 4, you get 52. So different ways, different tricks, you end up with the same answer. And 4 times 5, we know that's 20, right? Now, which ones can we add? Well, this looks like it's what? 48 and 52 would give you 100, and 100 plus 60 plus 20 would be 180. Right? So you don't really need your calculator all the time. You just need to maybe step back and look at what your numbers are and use your operation laws for them, right? Now, this question here, how is this different from the one above? Okay, they look the same because they're both triangular prism, but there's an additional information that you need for you to be able to figure out the surface area of this prism. What is that other information? I don't know if you noticed, but this length here is not given. So there is an unknown side, and that's the one you need to figure out first, right? And what could that be? Well, we know this is a right angled triangle. Yeah, and using the Pythagoras theorem, would be able to figure out what this value is. Okay, so let's do that first. Before we go ahead and figure out the surface area, let's maybe figure out first what we need, right? So how do we use the Pythagoras theorem? We say C is equal to the square root of what? 15 squared plus 8 squared. I think I need my calculator for this, which I did not bring with me today. So you've got square root of 225 plus 8 squared, which is 64. And what's 225 plus 64? You get what? 289. Oh, no, it's not. So it's 17. 8, 15, 17 is a Pythagoras triple. So you've got 17. Yeah. Right. So then if X there is 17, we can now go ahead and figure out 17. Let me just write it down. X equals 17. Yeah. So after that, you'd be able to figure out the answer in the same way as how you figured out this here. Okay, I won't do that for you anymore. Anyway, the example is in the textbook, so you can have a look at it. But for some of those questions that you will have to do, you will have to use the Pythagoras theorem to figure out the missing side. Okay. Now, example 3 is what we call a trapezoidal prism because its cross section is a trapezium. All right. So again, we want to figure out the surface area. We want to have the front, back, right, the top, the bottom, right? We need space for that. We want, what else? top, bottom, you've got the sides. The two sides are different, so you can't just simply double them, right? Although they're opposite sides, they would have different area. So you might probably want to just have the right side plus the left side, yeah? Right, let's go ahead and calculate the areas. We've got front and the back. We've got half A plus B times by H. What is our A? A is 7 plus 28, which is the bottom here. We times it by its height, which is 8. And then there's 2 of them, we double, right? We need the top, which is 7 by 20. That's 7 by 20 there, right? We've got the bottom, which is 28 by 20. And then we've got the right, which is 17 times 20. And then lastly, you've got what? You've got 10 times by, which is that one there. Yeah, wait. So you've got 10 and then times 20. Right, so we've got plus 10 times 20. Okay, so now we can cancel the half and the times by 2. We've got 7 and 28. We have 35 times 8. What's 7 times 20? It's 140. We've got 28 times 20. 28 times 2 is what? 56 times 10, 560 plus 17 times 20. You've got 34 times 10, you get 340. And then the last there would just be 200. Okay, what's 35 times 8? We can double it 3 times this time, right? Because we're timesing it by 8. We double 35, we get 70. Double it again, we get 140. Double it again is 280. Plus 140, plus 560, plus 340, plus 200. Okay, which ones can we add together? This one looks like what? 500 plus 300 plus 60 plus 40, that would be 900, right? So these two would be 900. What else can we add together? We've got 280 and 140, that becomes 420, sorry. 420, and then we have 200. 900 and 200 would give you 1,100, 1,520. Okay, right, and we just add in our units. So I hope that helps. Stay awesome. See you next lesson. Bye.
Come on, Rocky, let's go.